So this tutorial will be kind of an introduction to Dynamo. It's a computational modeler scripting language for Revit, similar to Grasshopper for Rhino, which allows you to take components or nodes, as they're called in Dynamo, components in Grasshopper, and link them together and do kind of mathematical operations on geometry or lists of data to then create flexibility within a model, for instance, that you're working on, or run through a bunch of iterations of something. So it's not kind of limited to modeling, but that's kind of the purpose that we're using it in the school. And so Dynamo is developed by Case. They're an architecture firm, kind of an architecture firm. They're a consultant firm that works with architecture firms to do digital fabrication and 3D modeling. And so they're trying to get Revit up to speed with kind of the freeform modeling software that Rhino can be. So I guess we can just dive right in. First of all, it's open source free software, and part of that means that it can be installed on all these computers. And since this was going to be added after the school year started, we can force installation of software through the Software Center. This is kind of a cool thing that IT has worked out. So if there's a piece of software that you're interested in getting on these computers and it's not the summer or winter break, talk to them about adding it to Software Center. And so I'll show you how to do that. So if you click Start, and down in the search menu, just type Software Center, and it'll be a program that pops up. And so this screen will show all the available software that's currently not installed on these computers that you can install. How Software Center works is it doesn't attach the installation to the image that's already on the computer. So every time you reset the computer, you're going to have to reinstall it. But this just allows quick deployment of rapidly changing software to be constantly updated. So if you click the checkbox next to Dynamo on the left and then click Install Selected, it should take a second or two, and the status over on the right area should say installing. A few pop-ups. Went much faster this morning. So when it's done, it should say installed. Does everybody have that installed? Yep, okay. So you can just close out this window now. We'll open up Revit 2014, so program files, or you can search for it under Autodesk, Revit 2014. And does you use 2014? I have used Dynamo with 14 and 15. I do not know if it works with 2013. But with your student email address, you should be able to get 3. Yeah, okay. Are you going to play along? Mm-hmm. So go to Software Center from the search bar on the Start menu. Once you get logged in, so just type Software Center, and then it'll let you install Dynamo. So we're going to set up the second half of the tutorial kind of first. So in the main window, just do a new project, architectural template. Ooh. And then this is a default template that doesn't come with a 3D view, so create a 3D view by clicking the little house. And then we're going to add visibility permission to massing, so hit VV, and it'll open your visibility and graphics overrides. Scroll down to mass and click the checkbox. VV, and then hit OK. And then we're going to add, we're going to place a component. So from the main architecture menu, component, place a component, and then you're going to want to go to load family, and we're going to load a mass from the mass folder, and we'll just check the first one, the arch. And so that should let you place an arch. Click place one and hit escape twice, and you should have an arch in there. So what Dynamo is, yeah, I just put a component in it. So place a component, and then click load family. Scroll down to mass, and then just do arch. So conceptual masses and a lot of other components in Revit have shared parameters that you can edit and they can flex. So for example, over in the left properties menu, it says the arch width is 30. We can change that to 40 and apply, and then it dynamically changes the arch. So we're going to use Dynamo to control this later on after I kind of get you familiar with the program. Now that that's all set up, you want to go over to the Add-ins tab at the top. And if you installed Dynamo correctly, there should be a button that says Dynamo 0.7. Click it once. A new window should pop up. I'll let Autodesk collect information because this is not my computer. And then this is kind of the welcome screen for Dynamo. So we're going to create a new project, so a new file, by clicking new. So is everybody at the screen? Okay.
So you gave the consent?
Yes, because it's a beta program and they're constantly working on it, so I feel like if when the computer crashes, it sends them information and they'll fix it. Yeah, just then click a new file. So this is the main Dynamo user interface. On the left, you'll have your library of nodes. So little pieces that you can interact with by feeding numbers into them, creating numbers or geometry, and then pushing that geometry to other nodes. This main screen is your kind of workspace, so where you're going to be laying out the nodes. And down in the bottom right, you can switch between node view and geometry view. When you click on geometry view, you can navigate around in three-dimensional space of whatever you're creating. So it kind of gives you a live preview behind what you're creating. And so I guess the interface is pretty straightforward, has your normal menu bars and stuff, but we can get straight into kind of what these nodes are and what they can do. Whenever you want to create a new node, you should use the search option. So we're going to create a point node. So type in point, and it'll search all the kind of point associated nodes within here. And we're going to want, under geometry, point create, we want the second node. If you hover over it, it says it's point by coordinates, has an X, a Y, and a Z coordinate associated with it. So you click that, double click that, and it should come up. Oh, am I in geometry? There we go. Okay. So make sure you're in node mode down on the bottom. If that didn't come up for you. So this is what a basic node looks like. On the left side, it will have inputs. This is a point node, so it's going to want information for its X position, Y position, Z position, and then it will create a point which that you can use on on the right side. The little square box on the bottom is kind of like a preview of what's going on in the node. Right now it says null because we're not feeding it any information. And so you can click that on and off to kind of show what's going on. So to create a point, we're going to need X, Y, and Z coordinates. So back over to the left on the search library prompt, type in number, enter, and I'll give you a floating point decimal number node that we can put numbers into and then send them to the coordinates. So we're going to create 3 of these. So if you just select the one you made and just copy, Control-C, Control-V, Control-V, and we'll have 3. These can be renamed so you can kind of follow what you're doing in your workflow by right-clicking on the name, rename X for the first one, rename node Y for the second one, and rename node Z for the third one. And that's just helpful to kind of understand what you're creating and where things are going when the script gets big and complicated. To connect these things, there's a little arrow on the right-hand side of the number nodes we created. If you click once, you get a little line, a dotted line, and that's how you connect from node to node. So we're going to drag that and then click on the X, drag that, click on the Y and the Z, and give these some values so we can see what's going on. So like 2 for X, I'm going to do 4 for Y and 5 for Z. So nothing's happening. Because this is a visual programming language, you have to tell the program to run to be able to create whatever you're trying to create. So down in the bottom left, there's a big run button, a cancel button that stops it from running, and then a run automatically. Depending on what we're doing, I like to have run automatically on generally. When you're working with a Revit file back and forth, I found that gets a little buggy, so I'd keep that off with a Revit file. But for right now, we can just click run automatically and then hit the run button. And you should see a little blue aqua dot on your grid. Oh. Okay, dark blue, yeah. So it turns aqua if you select the node that is creating it. Sorry about that. And then again, if you down in the bottom right, node is highlighted. If you click geometry, you can rotate around in 3D space and see kind of how that point is situating itself. If that gets distracting in the background while you're creating this, you can go up to View, Background 3D Preview, and turn that off. And then you'll just kind of get a node view. Without that visualization, there are 2 other ways that you can visualize while you're scripting. In the library, search for watch, W-A-T-C-H, and we'll have, there's under core view, we have watch and watch 3D. So create a watch and a watch 3D. I guess single click works, not double click. So watch 3D is like a miniature version of the background preview that we had turned on before, and you can drag the point from the points by coordinate on the right side of the node into the left side of the watch 3D, and then you can have a mini 3D kind of view of what's going on that once moused over you can move around and look at it. The watch node is more about the information that's passing through these. So if you connect the point to the watch, it says that we are giving it a point with a coordinate x of 2, y of 4, and z of 5 for mine. And these are a good way to visualize kind of lists of data, lists of numbers that you're creating and manipulating, and can then be passed through to other objects with the little string connector. Okay, I'm going to delete my Watch 3D and turn back on my background 3D preview. So let's make this point actually do something a little more interesting. With the number node, you can not only generate a single number, but you can generate lists of numbers. And we will do that by doing a little kind of syntax for this. Type 0, and that's going to be our lower limit of the list of numbers. Dot dot will go to 20. That's going to be the upper limit of the numbers. Dot dot, and then we'll do pound A, and so that's, and then enter. So right now we'll get an error. So when something's not working in Dynamo, it turns yellow. It gives you a little flag up top. It says there's no value that's coming through, so then you have to kind of figure out what's going on. The reason we're getting this error is because we put a variable in for the number of X values that we're going to create, and we're not bringing in that number into this node. So we need to create a slider. And if you type slider over in the search, you get two slider options, a double slider or an integer slider. Let's use the integer slider. And then this gives you a range of numbers based on what you define in this dropdown. And so a min of 0, a max of 100. We don't want, or I mean, for X coordinates, it can be 0, so that's not a concern right now. But what we're feeding it is a count. So a 0 count will still give us an error message. So if you drag the slider over into A, the point by coordinates will still error out because we're asking it to create a list of 20 items from, or a list of A items from 0 to 20, and A happens to be 0, so there won't be anything. If we change the slider to like 20, and making sure you have your run automatically still going, you'll see that in your background preview or your watch node that you'll have 24 points that show up. And if your X value, if you connect your X value to this watch node that we created earlier, it should show you a list of all those values. How lists are organized in Dynamo is from 0 to n, however many you have. So 0 will be the first item in your list, 1, 2, 3, and so forth. So we have 18 items as defined by the slider in the list that go from 0 to 20 as defined by our X coordinate number. And this is kind of a visualization of that list data. And in the background 3D preview, you can see that there are 18 points floating around. To make this a little more interesting, we can, I'm going to delete the Y and delete the Z. So that will give us just 18 points on the ground in the X direction. And I'm going to copy the points by coordinate node by Control-C, Control-V, and create another slider, integer slider. And this will be for our Z position of the second set of points. So if you drag that slider into the Z and then move it, you'll see a second set of points moving above the first set. I'm going to limit this one from 0 to 10, just so it doesn't fly off the screen. And as I move that slider, you can see those moving. So after points, geometry probably wants lines. So if you type in line, you will see down under the geometry line create, or no, that's not what we want. Yeah, at the top actually, geometry line create. And we want to create a line by start point and end point. We're going to use the first set of points and drag that over to the start point, and the second set of points, drag that over to the end point. And that should draw a bunch of lines. These could be representing columns or any number of other things that you're trying to draw, but most geometry, all geometry that you're going to be drawing in there, it could be broken down into lines and points, and then manipulating those lines and points from there. Since it's kind of a programming language, there's a lot of math operations that can kind of affect geometry. So we're going to search for the sine function. So just type sine, S-I-N-E, will still work, but yeah. And this will create, it will take the sine of a number and give you kind of that angle, like the math operation. And what it's asking for is a number in radians, and right now it's asking for a number in degrees. And so since we're using kind of these single values like 1.7 or 1.17, 9.412, we want to convert those to degrees. So we can type in rad to degrees. And connect double to angle from that math radians to degrees, math sign, and then we're going to bring that list of x values into the radians. If we click this number, it's going to give us a new list where it's taking that math operation onto our original list. And we're going to use this list of numbers for our y direction, our y coordinate on our first set of points. So if you drag that into y, you should see the points moving according to a sine wave. So I took the math sign from double and brought it up to the first point by coordinates y. And if we go back to our first integer slider we created where we gave it 18 points, we can increase that and it adds more definition to our sine function. This can also be placed in the y's if you want to mimic the top and the bottom. And you can start creating cool geometry with this stuff.
Could you invert too?
So it's an opposite curve, yeah. Now, list actions, I haven't gotten into it as much. I think we can right-click here. And so we can manipulate this list to create different things. Maybe I should bring this into a watch panel, so then I don't change the geometry for the first one. Does this allow me to do that? No, it does not. I guess, I mean, I'm assuming I could show you in Grasshopper.
The lines, like, I know they're straight lines, but it looks like they're like connected.
Yeah, so yours do not look like this.
Mine does not either.
He has a straight line at the top. I think mine looks like that, but.
Okay, so to create the lines, we have 2 point coordinates, and
So my second one's messed up.
Uh,
That one, yeah. Because mine's a straight line.
and mine's curvy.
Yeah, how do I make it look?
So I brought the sine function into both y,
Oh, gotcha.
so I can remove that top. So yours looks like that. Okay. So, with more time and practice, you can find lots of cool ways to manipulate numbers, to create geometry and stuff. That's the extent of my knowledge in this area. So I'm going to close this. I don't care about saving it, so I'll hit no. And the reason I'm closing that is because when I've started working with Revit files, after I played around with the nodes, I was getting some errors because this is a new software. So I just am going to start over and click new again from the main menu. And then I'm going to minimize this or pull down this window so it's not quite full screen. So I can see kind of what's going on in Revit. So, is everybody with me up to this point?
Okay, I can't find my 3D. It's not in here.
You have to create one on a new project file.
Yep, I did that, and I have it open. Oh, okay, there it is.
Okay, so back to this dynamic component. It has these 5 parameters that flex the component. What's important to note is what these are called, because we're going to be using those names in Dynamo to then create a link between the files. And you have to get the spelling exactly as it is with the spaces and everything, otherwise it won't work. So the components that we'll need to be able to manipulate the Revit parameters are select model element. So if you type select model, it'll be under the Revit selection, and then the first one, select model element node. So this allows us to bring in Revit geometry into Dynamo and start manipulating it. To bring it in, you want to click the select button, and then back in Revit, just click on our arch. And then down on the bottom it should say element ID something something something. I think that can be controlled by the properties of the element if you want to name it specifically.
Do you have to look up? Like when I type in select model, it says no search.
You typed exactly select model. So try canceling out of that.
Did I set it up wrong?
No, I did exactly the same as it was. Okay, so we've got our select model element and loaded in our Revit file. Then the next node we'll need is element set parameter by name. And so if you just type in set param, if you clear that first, set param, and then it'll be this set parameter by name. So this takes in an element, a string value, and a numerical value, or a variable. So we're going to connect the element to the top, and then we'll need to create a string node and a number node.
Hold on. For the string node?
Yep.
I found it.
So I had run automatically selected when I started this, and I'm already getting an error up top. That might be an issue, so we'll just try and see what happens. So before I break it, I'm going to put like 40 in the number node. And then in the string, I'm going to go back to my Revit file, and I'm going to type in width back in the string node. Now we'll try to run it. Okay, good, it changed. Width. So you could type in any of the dynamic parameters that Revit component or that you want. So I'm just choosing width.
I have like a yellow
Oh.
sign on top of my string.
On top of your string?
Yeah.
Is it connected to anything?
Yep, it's going to get the parameters.
Do you have run automatically selected at the bottom? Click run again.
Now all of them are the yellow sign.
Now all of them.
Yep.
Did your geometry change in Revit at all?
Nope.
No? Okay. So I'm going to change this to 50, hit enter, and mine changes, but I still get that yellow error.
Yep, I start changing.
Let's try to reassociate this. And so this happens.
Is this our
So
does that get this question?
it just crashed. Yeah.
Oh, it's not very nicely.
And so I can't even get into Revit. So I think the whole thing is crashing.
Came about this computer then?
But my all the four labels are in yellow, but the Revit model is changed.
It is changing?
It is kind
Okay.
of how you like make the dots.
Yes.
Okay. So if you hover above it, it'll tell you failed to obtain this object for, but it obviously did obtain it.
Yeah.
So I don't know what to say besides, I mean, it's working.
Yeah.
Okay. Is yours working? Are you having fun scripting and playing around?
Yeah, pretty much fine.
Okay.
I didn't even get it open. I missed the first 5 minutes. Watching along.
To install it on these computers, yeah, you have to go to Software Center down there. You type in Software Center.
Oh, I got you. Yeah, I tried to download it.
So that's where you click.
Oh, nice.
And then you probably have to reload that. That's my exploration of this tool so far. So it has a link between Revit. You can push geometry back to Revit. I haven't kind of quite figured that out yet.
I have a question, I mean, not that I know Grasshopper, but like,
Yeah.
have you found it to be easier than Grasshopper, is it different?
Um, I just think, well, I think the nodes are explained a little bit better
Yeah.
than in Grasshopper. It's kind of it's been easier for me to understand what nodes want and what nodes are going to do.
Yeah.
Um,
So, like, do more information too, like give it more information. I don't know.
the stuff that I've gotten into in Grasshopper is like heavy tree data structure manipulation, and I haven't gotten that far in Dynamo yet. It was for me a steep learning curve in Grasshopper, so I imagine it will be
Yeah.
in Dynamo as well. What I'm interested in continuing exploring in this is uh, an additional plugin that we can't get on these computers called Rhino, and that brings in Rhino geometry into Dynamo and then into Revit. So you can start taking your kind of conceptual masses from Rhino and turning it into real building types.
So it can help to build some complicated forms in Revit.
Yep. And then, so yeah, so a complicated form in Rhino that you could turn into Revit walls, Revit floors, and etc. that work like the generic dumb Revit components, but are your more interesting geometry.
Have you tried rendering with the master created it?
Rendering with what?
With for example, you create that curving wall a while ago. Have you tried putting that in Revit and then tried rendering it? With just Revit ripples or?
So the tutorial kind of stopped there and moved to this port because I couldn't get my geometry to go into Revit. I don't think I've studied it enough. But I would assume yes, based on all the videos from, and so I mean, if you're interested in this, there's cool introduction videos and stuff at dynamobim.org.
Can we see a picture of like a Dynamo with it rendered? Fast forward to that, at least want to see the final product.
Yeah. So it looks like he's taking this and turning it into structural elements
Okay.
in Revit. Something that wouldn't have been as easy to model
Yeah.
straight out of Revit. So,
I'm just curious if Revit can properly render it. Then you messed up mass and
oh, I assume it would be able to.
remember the materials, will the materials come out quirky or?
So say you applied a brick texture to that. I mean,
Okay,
it would it'd probably look weird just because of how that you wouldn't make brick necessarily in real life. But I don't know. I would say yes. Any geometry that you can get into Revit can render as well as Revit can render it, which I would argue is not very well.
I have a question. In the first case, I only get